Association. So today, well, topic is really interesting. We have a excellent topic about digital infrastructures, asset management, and toward into smart city and so on. And of course, nevertheless, we having two excellent speakers. We actually keen have a lot of experience all over the place, all around, in Europe, Middle East, Southeast Asia, and so on. And here they are here. So well, hello, Chris and Sonny, of course. Well, thank you to both of you for joining our sessions this evening. And I think this topic is very interesting, especially for Southeast Asia, Thailand specifically. And since from the past few years, we have a lot of development in infrastructures, and the new town, new city keep coming up and develop it though. So I guess based on a great sample from the speakers today, I think we will have a good lesson learned and some samples that we can take it away. Anyhow, well, thank you both of you for joining us. So let's begin then. It's a bit of casual today, so may I invite the first speaker for this evening, Mr. Christopher Smeaton. Then give it away to you, Chris.
Yeah, thank you, San. So like San said, my name's Chris Smeaton. I'm the digital practice leader for Vietnam and Singapore for Aurecon. I also involved with a lot of the digital planning across Asia as well for Singapore. Not for Singapore, sorry, for Aurecon. My experience, I've got just over 14 years experience in the industry, and like San said, that's across different markets. I started off originally in the UK, then in the Middle East, and then across to Asia. I also bring a lot of different experience. I everywhere from interior architecture, furniture design, landscape architecture and urban planning to engineering. So throughout my career, I've built up a lot of different portfolios and a lot of different experience, all the way as well from Revit authoring. So I've built a lot of families for different companies. I've also done a lot of company standards and visualization. So my experience is vast, and it really helps when we're trying to drive digital in the company, because I can talk everything from the executive level all the way down to the modelers and the visualization team, and I can also do that process, so it really helps there. I've also a accredited professional by BRE on the ISO 19650. Along with that, I passed a course with MIT on smart cities, design and emerging technologies last month, which was very good. I do a lot of smart city advising on projects here across Asia and also in Australia. Also, I've won Building Excellence Awards as well for digital implementation and so on. So today I'm going to have a chat to you about like digital twinning, as people like to call it, asset management really, and what we've kind of done with this campus, which is RMIT here in Vietnam. So the RMIT is a very forward-thinking university. They're really wanting to go along the digital transformation. We've done a lot of work with RMIT in the past, and they approached us to help them with this transformation. Now, here in Ho Chi Minh City, the university has over 8,500 students. There's 6 buildings, and they're also a self-contained campus. So they have the library, lecture halls, IT labs, STP building and so on. So they've got a lot of assets that they maintain and have to monitor throughout this site. So I'd like to start with just understanding what I think a digital twin is, because this is quite a good topic in the industry, because I normally sit there listening to people talk about digital twin, thinking exactly what I've got here, that actually what I think it is may not be what you think it is. And that's a common thread that I'm seeing, and it's now getting re-engineered in the industry. People are now understanding the benefits of digital twinning and what it actually is, because when I first started looking at it, it was mainly people were doing a 3D model, hosting it online and saying, look, here we go, we've got a digital twin. And I'm just like, yeah, that's a lovely 3D model, but I can't do anything with it. So when I look into digital twinning, there's three main topics, and they break out into separate identities here. So my first one is analytics. Okay, you've got to have analytics within your digital twin to call it a true digital twin, and it has to be real time. Okay, it's got to be good quality, and you've got to try and run predictive analysis out of those analytics. It's got to be open data, so accessed anywhere. It's got to be federated, so all the information is in one place, and it's also got to be dynamic. It's got to change over time. It can't be a standard solution that just is fixed in time, because our assets and what we do with them mature over time and may change. And it's got to have industry context. Okay, because when we talk about digital twinning, it can apply to many different things, like a pump, a rocket, or a building, or even infrastructure, obviously. So when we talk about linear infrastructure and we talk about buildings, they all have specific needs from a digital twin, and our clients have specific elements that they want to get out and information they want to leverage. So when we look at this process, we really have to make sure that we understand the industry context it's going into and what the users need at the end. So if we look at a possible approach that we normally lead to a digital twin, we normally start with around the data capture. So seeing what information we have on site. Then we establish the data sets. So we then get all the information, standardize it, and make it into all the data sets that we need. We start to look at insights into the data. So what we can establish from that data. So, how can we use that data? And then we go into our digital interface. So our digital twin that most people see is how we visualize that data. Because this is one of the most important parts for the end user, is taking the rows and rows of data sets and putting it into a visual format that we can understand. And that is what most people think when they look at digital twinning, and they don't think about the information exchange that's gone into this and where we're getting this structured data from. So when we look at the experience that Aurecon have in this, we've been doing digital platforms for quite a while. We purchased a company called Unsigned Studio about 4 years ago, which are a visualization and technology company, and they have developed online platforms, one of which is called SiteLab. This enables us to bring all of our digital technologies together in one place. We can leverage all of our information from our design information to asset information on site. And I'll explain about that a little bit in the as we go through this presentation. So on the far left-hand side, this is one of our own buildings, one of our buildings in Australia. One of the first digital twins we tried to do with this platform, where we linked it to different data sets we could get. The next one along, we went into a little bit more detail. This is what we call the Treehouse Project, and this is our own building in Brisbane. And we started to link in not only our information asset information, but also the energy usage. We were doing site inspection reports and bringing all that into the one system. So we were able to start running a lot of analytics on that and starting to optimize our building based on that data. And then we have on the far side our city, our SiteLab City that we have, and that's our city wide application. And I'll talk about that a little bit in the coming slides. So moving into creating a digital twin, or looking at how we establish digital enablement for our clients, we've broke it down into like business process and ownership, information management, and digital technology and solutions. So if we have a look about that in the process a little bit more, we've got the information requirement specifications. Under information management, this is like where we standardize our data. And then we have obviously our digital technology solution, and this is where we store our data, or where our clients have our data storage. And then we have the end user. So we had a look at current states of most of our clients, and we traffic light them. So you can see around the business processes, around information requirements and user user information or the use of information, we found that not a lot of the clients had that well established, if any. We tend to find that a lot of the clients will have information in a structured standard way of some sort. And then a lot of clients obviously have their information storage and how they present and aggregate that data on using different platforms. A lot of clients normally have some kind of solution around there. So what we do is we step in with our clients and we workshop with them to find out what information they need to use, and also how they can embed this into the other workflows to try and make the data sets a lot more clear as we move through this process. And we do that by providing support at each one of these stages, having a look at gaps in their information and how we can help improve the processes for the client around that capture moving forward. So we did this with our client on this project, and where we see digital twinning sits in between that information management side and the digital solution. But to get there, we need to make sure that we've got the end of use or the use of information in mind, and also the information requirement specifications at the beginning. And that really enables us to build a good solution around how we manage and show our data at the end for our client. So a typical approach that we've used, and this one we've used with our client here, is like almost like a 6-stage approach. Depending on what our client's needs are, this might change. But the particular client here, we had the first strategy meeting where we sat down and we had a chat about their aspirations, what they needed to do, and we scoped that up for them. And then we broke it down into the 6 different into the other stages. So into data collection, data enhancement, data access, analytics, and then the digital estate governance. So how you're going to monitor and improve that moving forward. So we broke it down into all these different stages, because normally when we look at digital twinning with a client, you mention that to them, it's a very, very out there way of thinking for some of our clients. So breaking it down into different into each one of these areas and giving a clear key deliverables at each one of the stage really helps our client understand the benefits they're going to get as we move through this process with them, because it's a journey for them as much as us. We need to learn about our clients' needs and how we can help our client, and also our client then can learn how they can leverage that information to better enhance this system as we're moving through. Okay, and it gives that flexibility as we move through the process. So after we've moved through that, we then have to go through the data collection phase. So this is where we gather all of the data from our client and start to look at what we need to do with it. So we break it down into the 2D data. Do they have any 3D information? What asset information do they have? What are they using? Which different platforms they might be using? And then the formats in which they're saved in. And then we create a gap analysis, and then we have to go and start to either enhance that data or go and capture that data where they might not have any. Now, this particular client, we had a mixture of 2D data, 3D data, asset information. So we started, because we're on quite a tight program for this, so we had to start the digitalization of the models, or the enhancement of the 3D models, because they had a certain aspect of that, as well as the capture of the data or the on-site data, so we can verify it later. So what we did is we split it down into 2 teams. So we had the team that was digitizing and improving the as-built information they had into the 3D environment, and we had our site team were out there scanning the site to get the verification that was needed for the accuracy of this process. Now, I'm not an advocate of saying that every project needs an actual 3D model to be a digital twin. This client had specific requirements of using this model for refurb work and extensions and possible work as they move forward. So the model became very important to them from a point of view that they would use the model later to give to other consultants for them to enhance, and then it would be pushed back into this system. Okay. Otherwise, if you weren't looking at doing that, you could possibly just use the scan data. But there's pros and cons from that, depending on what you're trying to achieve for your client moving at the end of the process. One thing to keep in mind when you're looking at capturing data and doing this type of process is the size of this data, and this really helps. To help you with this, it really enforces the fact that you need to start looking at maybe your digital risk assessments and also doing your digital work planning before you move into the project. And you scope this under the first stages when we do our workshop with our client, because not only is it a challenge for us as the consultant, it will also be a challenge for your client. So this particular project, the raw data alone was 5 terabytes. And once we processed that data, it was over 20 terabytes of data. And that was just the scan information, let alone all the other information that we had to build through the 3D modeling. And then you've really got to think of how you manage that data in your own IT systems. You know, how you're going to link that into your models. Have you segregated it in the right way? Can you optimize it for modeling? And also, how you're going to deliver that to your client. Your client might not have the infrastructure to absorb that amount of data. So it's a real key to have a think about before you start on this process, and have that open conversation with your client. So once we started on the project, we established georeferencing around the site, because, like I said, this was the beginning of a journey, and there may be new buildings, there may be refurb work, so further scanning might happen on site. And plus, we had no way of geolocating the site for the client, given the information that we had, because that wasn't captured. So we went to site and we created all the referencing and the ground points for the client. So later on, if they ever wanted to do scanning again on that site, they have the reference points that they can do, and it can be pulled straight in without having to try and reference it all again. And this was the equipment that we used. So the different technology we used on this project was around the site. We used the Pegasus backpack. All the equipment we used was Leica systems, and a company called GeoInstinct here in Vietnam partnered with us to do the scanning. So the Pegasus backpack was used for external scanning. Extremely good. You just put it on your back and you can walk around the site, and it does all the capture for you. The quality is really good as well. The only downside to it is the equipment is about $300,000 worth of backpack. So you have to make sure that you don't fall over. But this it was a really good capture. And then the internals of the buildings, we used the RTC 360. The quality and accuracy of that scanner was probably far beyond what we actually needed, but give our client a lot of information and give us some really solid information to do the verification with. The other great thing about this camera, about this scanner, is it captured 360-degree photos everywhere that we did a scan, which really enhanced the ability to QA/QC these models as we were moving forward through the verification. So when we talk about verification on this project, we used the various different tools. Obviously, we compared the 2D CAD drawings to the BIM model to do the gap analysis. We tagged all the assets. So GeoInstinct, when they were going around on site with the scanners, whenever they came across an asset tag, they took a picture of it and it geolocated it within the 3D scanner, which then brought it into the point cloud. It really helped with this QA/QC system. We also used Revitso, because it was a really good platform for us to bring our client into and give them that experience of working with our team. And we found it really, really successful, actually. We were concerned at the beginning how it would work, but our client was in there and they were taking photos on site and uploading photos and giving us that real-time feedback when we were doing the modeling. And that really helped when we were waiting for the point cloud data to come in, that we could already start the verification from the information that our clients gave. And that really brought the trust between us and the client. Then we had to think about how we were going to use this point cloud data to model. So there's a couple of ways we could approach this, and we have approached this in the past, is we could create a mesh. That's probably going to make the easiest way of us dealing with this. And we've done this before. We can upload it to BIM 360, so you can share it with the rest of the team. And we can add these teardrops of information through it, and we can attach photos and things to that. Now, it's really good because the system we used color matching when it came to the triangulation. So if there was two triangulated points near each other, but they had the same color, it would delete them, and it really reduced the file size. The only problem with this is it's just one big object. Okay, so it's not object-based modeling, which caused us a bit of issue if we're wanting to use it for automation. So what we decided to do in the end was to use Jetstream Viewer for the client, and you can see that in the bottom end of the screen. And we use CloudWorks, and what CloudWorks allowed us to do is link in an LGS file directly into Revit. The LGS files are really light. This video was recorded on a tablet that I have that barely just runs Revit, but was able to link in this 1 terabyte data worth 1 terabyte file into Revit, and it worked really well. What this enables us to use is the inbuilt tools for automation. So CloudWorks has piping and wall automation. So we're able to click on piping, and it will. I'll just, if I can get my, just fast forward it a little bit for you guys. So you can choose the different piping and select on that, and what CloudWorks will do is identify the piping from the point cloud just from where you click, and it'll give you a few options, but then you can just okay it, and then just go through and click the pipes. It'll also do the automatic joints as well. So once you've done that, just wait for it to catch up. You can then use the joint command and pick the two pipes, and it will join the pipes for you and add the connection in there. So this really speeds up the process, and this is why we decided to go for the object-based modeling approach, because it helped us to create this from verified information. Okay, which was really good. The other aspect that doing the 3D scans helped with the client was we were able to give Jetstream Viewer to the client, and halfway through this project is when COVID hit. So our clients were able to use this information when they were at home and carry on with their investigations they had around their assets and looking at the condition while they were offsite, which really helped them. The next stage was verification. So we use a program called Verity that compares the point cloud and the 3D model together, and then gives you a report of where it doesn't fall in line with tolerance. And it'll also tell you what's in the model that isn't in the point cloud, and objects that are in the point cloud aren't in the model. Now, we've used this for verification of as-built and also verification during the construction phase. So we can see if actually the program is following the construction sequence properly, or if there's things missing, which really can help the client. The next thing was connecting the data. So we talked about our SiteLab application, and our client are using Archibus. And what we didn't want to create is two systems. So, you know, we've got BIM 360 that hosts all the models. We've got Archibus that holds all of the asset information. And then we have our SiteLab application that is the interface for our clients to go out on site and use this application. So what we did is we created the API link between Archibus and SiteLab, which helps us push information back and forward between the two systems. And it also links the information in from BIM 360. So we created this whole system that is basically your one source of truth for your digital model. The client is now able to go out on site with their iPad, pick on an asset, fill in an asset form to tell us like the condition of that asset, and then when it's submitted and approved, it pushes it directly to Archibus. And then if they're having to do any updates on Archibus, that is also pushed back through to the system. So we're starting to build this really connected system for how they can accurately monitor their assets. So, oh, sorry, just go back. So this was during the test phase. So this isn't the finished article. This was when we were doing our testing for the client. But this gives you the idea of what the information looks like when we bring it into SiteLab. So you're able to this just has some of the functionalities in this build that we have now. We have a lot more of the functionalities, but you can go in and you can click on assets and you can see this has all of this information. Now we've tied that information back to Archibus so that we can, like I said, push and pull that information back and forward. We're able to tie in sensors into that, so noise sensors, heat sensors, or any other sensors that the client might have, and we're looking at different opportunities of bringing more sensors in to establish a better solution for our client. Okay. So moving on from that, what's next? So we do a lot of asset forecasting for some of our clients, and this is when I say that a digital twin doesn't have to specifically be a 3D model, because most digital twins you'll find that comes through actually management of assets. So depending on what you're wanting to get out of your asset management is the solution that you choose. So in this regard, we were able to take all of the asset renewal forecasting for the client and condition assessments and everything else and build it into this type of platform. So our next stage for what we're doing with the platform that we've just shown you is we're tying in all of this information and connecting our systems. So we're able to do the asset renewal forecasting and do these analytics based on the assets and the information live that we're getting from site. We've already got the two systems, we're just bringing them together now. And we've done it for a few of our clients. The other thing we can do now that we have this information is this is an example of where we have our own AI systems that have a look at this information that we're gathering on site through the sensors. And this particular solution, we focus it towards HVAC. So we're able to optimize the HVAC systems for our client using our AI algorithms. So this has been really good. We've managed to bring in quite a lot of savings for our clients on this. We've rolled it out to a lot of the market now, and our findings originally when we first started this out was large proportion of the buildings, the plant was incorrectly controlled, which was really quick for us to identify and help our clients to manage that. But also the trends of the operating hours of when these assets were used, and then try to predict how they could be used in a more efficient way. And we really brought a lot of benefit that way. Sorry. So the next stage of this is where we look at smart cities and digital twinning bringing a real benefit to our industry and to the way that we look at data is when we start connecting them. So when we start to have a city of smart cities, digital twins, and connect them together to start to monitor how our cities are running, how efficient our cities are, and how we can use that information to better design our cities or better enhance the infrastructure that we have. Now, SiteLab City, we've already started to do this with the likes of Melbourne, Brisbane, and Sydney. We've brought this into this system, and we're able to do a lot already. So we can bring in like flight records, we can bring in pedestrian movement, we can bring in traffic controls, any of that data that the city has available, we can start plugging into this system, including different zones, as well as building permits that are outstanding, people that have new buildings that are getting developed and so on. So we're able to start to really look at that. And that really helps with like stakeholder engagement. We've got from there, we can have a look at who is actually opening the system from around the world, what they're looking at, start to really aggregate that data to see what sort of people are maybe looking to investing in the city, what areas they're looking at, what is of interest to them, and start to run the analytics and reports from that. And the other thing is we've started to pull in like financial modeling, having a look at the finances of the city, how it's doing, and doing the city monitoring, pedestrian monitoring, and things like that. So we can start to do the analytics about where we might want to start looking at enhancing the mobility in certain areas. How how the financial district works and so on. So these platforms are becoming extremely important, and we're starting to leverage this quite extensively now for our clients. So my last comments with this is, when we start looking at these smart cities and digital twinning for our clients, and how we can leverage all of this data to better suit our needs and our clients' needs, as long as we remember the three main aspects, I think, we need to be able to run analytics. So if you can't run analytics from the platform, you're not bringing best practice to your client or best benefit from what we're doing. It needs to be open. So it needs to be open data. So we need to be able to pull that data in from multiple of different sources, so that we can QA, so we can quality assure it, make sure that we take out any inconsistencies in that data. And it needs to be have industry context. So you need to know why you're doing it, what the end user is going to use it for, and what is going to bring most benefit. And that's it for me.
Wow, that's excellent. Yeah, I just want to jump in, but I it's like a trend. Yeah, I don't want to just interrupt though. Excellent informations and knowledge though. Quite a few questions and technical questions actually.
Yep.
So once you do like those kind of laser scanning, different kind of tools, equipment, walk along, the station and so on, is that because you need to join all elements and point, that's why you use one? Is that matter to choose only Leica, instead of mixing different tools or application, different brand?
No, I mean the main reason why we went down the Leica front is we partnered with GeoInstinct, and GeoInstinct are a Leica partner, so all of their equipment use Leica. The other thing is we use, when I said we use like CloudWorks, that's a Leica product. Jetstream Viewer is a Leica product as well. So it just really helped with that, with those workflows that we were doing.
I see. Make things procedures easier.
Yes.
Oh, all right then. Okay. It's a lot of story. I believe that what's the challenge here? What's the most difficulty in order to get this information?
So there is a couple of challenges. The first challenge is obviously trying to get a base point, so trying to find all the data, assess it, and get all the gap analysis, because sometimes that can be quite difficult. The next thing is obviously managing expectations and focusing on what is actually necessary.
I see.
Because as soon as you start to build anything in 3D for a start, people get overexcited and they start modeling everything when you really don't need to.
Okay.
And the other issue, another point that was very interesting point to look at is, like I was saying, the data, being able to manage that amount of data. That is a huge challenge whenever you're looking at capturing on-site conditions.
I see. My personal question is that would like to know, like, how do you say to clients that this is too much? It's a kind of trick question, is that, because I guess that pretty much the same, this, once you, like you're saying, you start to build up a lot of 3D, and then a lot of requirements come across. Let's build those things, and getting more and more. How you say no?
Well, it's just about building up that relationship with your client, and scoping it at the beginning. So we had a good scope at the beginning. We identified that when it came to assets, we only wanted like maintainable assets, things that were going to bring massive benefit to the client. And not focus so much on like furniture and the likes, because that doesn't really bring very much benefit to the client. And we really want to see how we can run analytics on the HVAC systems, how they use electric, things like that. That is where they're going to save the most money. So we always have to try and pull it back to there. And you're right. I mean, on these sorts of projects, we've had clients come back to us and say, oh look, our chairs are the wrong color. Or we want you to model the fencing outside and things like that, and we have to say, okay, yeah, we can do all that.
Yeah.
But do you want us to spend our time doing that? Because we need to start to look at why. Is it actually going to affect your business if your chair's blue or or red at this moment, or is that fence actually bringing you any benefit to your project? And we need to just have those open conversations and pull it back to why we're doing this.
I see. That's a good point, actually. Come across this a lot multiple data, different techniques. What would be the most difficult data that you has been captured?
The most
difficult and challenged data that you has been captured. Which type of data do you think that's the most challenges?
Well, there's a few bits of data that's challenging. One is obviously services, because not all services can be viewed. So you have the challenges of trying to get to that stuff that's hidden, because scan data you can't see through walls, and sometimes clients want you to capture everything, and you have to bear in mind, if you want us to capture that hidden stuff, it's gonna cause quite a lot of disruption. The other challenge is actually capturing the usage data from the assets. So a lot of BMS systems, they capture the data and they keep it within the system, and you can't get it out. So there becomes a challenge of how you capture that data before it gets into the BMS system, and that's when we can start to run our analytics from. Luckily, we've got a lot of experience with that, and we've been doing a lot of that within Aurecon. But yeah, that's probably two of the main challenges that we've had with these types of projects.
Excellent. Yeah, thank you, though. I think just kind of few questions as technical for this moment. I think we're gonna have time for a long discussion afterwards for sure. Maybe it's good time, so would give it to Sonny for the second presentation for the presenter.
Okay, yeah.
Okay, thank you, though. Give the way to you.
Sorry, can you see my screen now?
Good.
Okay, all right. Good good evening to all of you, or good afternoon. I'm Sonny Andalis. I'm Senior Executive BIM Manager for the Digital Management Office at Surbana Jurong, presenting to you the project that I was involved in, Virtual Singapore, roughly 3 years ago. So most of this is actually 3 years old already. Yeah. Okay, so the Virtual Singapore project actually came about from the Smart Nation project that was actually directly connected with the Prime Minister Office. The tagline for that is many smart ideas, one smart nation. So there was a declaration a while back that Singapore will be a smart nation, and then the very first thing that they would like to do is to create a 3D model of the entire country or the entire city. And that's the Virtual Singapore project. The Virtual Singapore project is basically the nation's digital twin, as mentioned by Chris. That's a new word, a digital twin. So that was actually the aim. So the NRF, or the National Research Foundation of Singapore, and the Singapore Land Authority has collaborated with a French software firm, Dassault Systems, specifically to create a 3D model of the entire Singapore. So this was actually an ad at the newspaper, and it was actually launched officially in 2018, which is basically 2 years ago. So as mentioned, this is a project from the NRF. That's the founder and the coordinator. The technical manager is actually GovTech, formerly IDA, and the Singapore Land Authority is actually the system owner, and the R&D partner is Dassault System, which is a French company. So the idea is to virtualize, visualize, and venturize. So we call it ViewCube. So Singapore is not the first one who did this. Cities from Chicago, New York, and the city of London they all have a 3D model of their cities. Specifically for London is the Digital Built Britain, so they have that. So it's not something unique to Singapore. A few cities has already done that as well. So what I'm trying to say here is that some of the agencies, like for example the SLA, Singapore Land Authority, is contributing, for example, the national topographic mapping in 3D. The building information model is actually contributed by the Building and Construction Authority for regulatory submissions. And then the geospace is actually contributing the data-rich environment. So different data sets contributed by different agencies. So the idea is basically very simple, is to have a clone, a digital clone of the city-state of Singapore, where you have the data, you have details or a level of detail, you have discovery. You can actually discover new things. It can be used basically model. So they pointed out a few benefits for that. So this is also another one. So a few agencies or news agencies actually pick that up. So Singapore to build is Asia's first 3D semantic map of a country. It's quite small, obviously. It's Singapore is quite small. It's basically a city. So SLA actually funded it, and in reality, actually, the virtual Singapore has 3 layers. So you can see from this. There is a master plan 2014. That's the upper layer, which is basically the above ground. The second layer is underground master plan. That is actually phase 2. And phase 3 is the geology. So actually it has 3 layers. So above ground, below ground, and soil. Or the geology of Singapore. So it has 3 distinct layers. So what I'm discussing to you is just the phase 1, which is the above ground. So this is a timeline of the project when we started that, June 2015 to June 2017, 2 years for the data capture. 2016 and 2018 are basically testing the virtual Singapore platform. And then 2018 to now is basically managing and operating that particular 3D model. Okay. So what's the idea all about? So basically it's composed of 3. So first one is data capture. City scale 3D models at various levels of detail. It's predominantly composed of point clouds, basically laser scanning, and digital surface models that actually created, or DTMs, created coming from photogrammetry. And there are apps, so I'll discuss that later. So there were a lot of discussion on what are the uses, the 3D applications that are not feasible to implement it in 2D. So obviously we have experience in GIS before, but we would like to implement it on a 3D scale. So there's a lot of apps that has been developed. And then the outcome, what's the accuracy, the interpretation of the results, because we did a few simulation to that particular 3D model. So this is actually coming from, we have a collaboration with Delft University from the Netherlands. So the applications that we're looking at is visibility analysis, energy demand estimation, emergency response. It can be used for shadow estimation or utility management completely underground, solar potential, because Singapore is basically a tropical country. So there's a lot of, we would like to identify the solar potential, the 3D cadastry, and so on. So there's a lot of proposed uses or use case of the 3D model. But predominantly at the time that this was actually started, the purpose was haze propagation. As you know, Singapore at the time, August, September, October, there's a lot of burning from Indonesia. So we would like to actually simulate haze propagation. So that was the original, how to say this, use case. Solar orientation, because obviously we would like to put up solar panels to the roofs to maximize, the position of Singapore being at the equator. And then shading and cooling, because they promote sustainability. So obviously, being at the equator or at the tropical country, there's a lot of usage of air conditioning. So they would like to seriously consider sustainability to allow to simulate shading and cooling, natural ventilation, basically. That's what I'm trying to say. So let's talk about data capture. So the Singapore Land Authority actually created two distinct data sets. That's the oblique and the nadir. That's basically the inclined and then the vertical imagery, and high density LiDAR. So similar to what Chris presented, we use actually laser scanners to actually create point clouds. So this is actually the LiDAR flight paths. So we actually mounted the LiDAR scanner onto an airplane, fly it around Singapore, and we created this. That's the images that was actually captured. And then similar to what was actually Chris mentioned, right? The backpack, the infamous backpack. So that was actually used to supplement the imagery. Basically, this is terrestrial imaging. So the laser scanner was actually mounted onto a car, and to supplement it, actually, this is actually another Chris from AAM, an Australian company. Actually, I don't know if Chris actually knows that. Yeah.
You
So
may
that
know.
yes. So terrestrial scanning on the road, that is actually what's happening. It's basically similar as Google Maps, but Google Maps is using photogrammetry. We have both. So we have photogrammetry and terrestrial scanning using laser scanners. So that's basically the output that we have. And then we started creating what we call city objects. So we have, bollards, bus stops, stations, basically traffic lights, and so on. So we created those cityscape objects. This is actually ERP, which is basically toll gates in Singapore. And then we created this imagery, this 3D model. So we started building the 3D model of Singapore from scratch. So those you can see here, bus stops and so on and so forth, including trees. Actually, it's a painstaking work because this is not an automated one at the time. There is an army of modelers behind this. That is actually creating the 3D model of the city. So it was not an automated one. It's very painful. But this was actually created. So in summary, there's a lot of panoramic images that was actually captured. That's 487,000. 579 million LiDAR points was actually captured at the time here. Okay, so we actually drove roughly 50,000 kilometers. So that's basically in addition to the photogrammetry coming from the plane. There's actually terrestrial scanning from the car. 50,000 kilometers was actually driven, 3 drivers, 2 surveyors, 12 hours a day with 2 cars. That's 14 plus terabytes of processed data, and then roughly 45 terabytes of the road data that was actually collected. Model enhancement, obviously, this is actually to basically polish the laser scan and photogrammetry coming from the HDB blocks. That's the public housing in Singapore. And this is the actual final product at the time, 2016, 2017, that was actually featured from an exposition, an exhibit. Yeah. So one of the reasons why we have gone through that is because there was a problem that we have. So this is obviously GIS. You cannot distinguish between the airspace lot and the subterranean lots. So there's a reason why we actually delved to, so that was actually phase 1. That's the above ground. So, but there is a more serious one problem, which is underground. So that's I mentioned before, right? So Virtual Singapore has 3 layers, basically: above ground, below ground, and then geology, 3D geology. So this is the second one, phase 2 of the project. So I mentioned about Geospace. Geospace is basically the government GIS system. It has 924 data layers. It's only accessible to the public agencies. This is basically the government-wide GIS platform. It's a private one. There's a public-facing one called OneMap that is available to the public, and it includes 104 data layers that can be accessed by business, academia, citizens, and NGO. So what we have done is basically ask the different agencies what do you need the model? So for example, the URA, the Urban Redevelopment Authority, is asking for digital terrain models and 3D buildings, and they would like to use that for urban planning, specifically underground, the usage of planning for underground works. So these are the things that the different agencies actually ask for, what they would like it to do. For example, N parks, we actually laser scan terrain and the trees because they would like to conduct biological studies and so on. So we ask every single agency, what do they intend to use it for? Okay. Denmark and Switzerland already have national 3D maps, so it's not something unique. Hong Kong has also conducted 3D mapping of their central business district. So we just follow the applications from other countries. So this is the level of detail. So what we said to them is that, okay, so if you have a particular need, so this particular agency will have architectural models, for example. This particular agency will have detailed models that includes the roof and the facade because they're using it for urban planning. Textured models will be used for this particular locations and so on, up to basically this is what this particular level of detail is actually following the CTGML level of details, from 0, 1, 2, 3, and 4. So this is what I meant by this. So LOD is 0. So as you see from the previous slide, it just talks about terrain. So okay, LOD1 is basically the shape of the buildings. LOD2 is textured, and then LOD3 is basically the BIM models, and LOD4 actually LOD3 and 4 are actually the BIM models, the 3D models coming from Revit, ArchiCAD, Tekla Structures, and so on. So there's a level of detail that is assigned to the agencies. So these are all actually incorporated inside Virtual Singapore. And then there was a question about format. So what format are we going to use for this very big data set? So there was two competing formats that we have evaluated. It was CityGML and then Land XML. So there's a big difference between the two, obviously, but we like the fact at the time, that CityGML is neutral, it's open format, and then it's supported by OGC, the Open Geospatial Consortium. And then we have, a feasibility study, a comparison study between the two of them. And then Ordnance Survey from the UK actually supported us and then pushed for, and then it was decided to actually use CityGML. So let's talk about CityGML. What exactly do you need to model? So these are two different distinct examples. So the one on the left, if you see here, this is obviously above ground. So these are the things that needs to be modeled or extracted from a 3D model, from Revit, for example, or Open Buildings, or ArchiCAD. And the one on the right is actually a 3D, an example of the specifications that was actually required for underground structures. Because as mentioned, there are 3 layers of Virtual Singapore that is basically covering the above ground on the left and then the below ground structures. These are the things that needs to be captured, including, MRT lines, tunnels, underground pedestrian, foundation, what type of ERSs was used, what type of rack bolt was actually used, or there's a knockout panel, and so on and so forth. So it's actually very detailed. Yeah. So let's talk about the uses. So it's already fully operational. This is a typical uses. This was actually featured in one of the Chinese newspaper. So one of the typical uses that was actually Virtual Singapore was used for is aggregating the data. The platform, if you see here, is actually 3D Experience City from Dassault, and then it can actually color code the annual electricity consumption of every building. So for example, this particular red building here consume X amount of energy. So they will be asking, why are you consuming too much? That might be a mall or an office building, and the rest of the building are basically like residential only. So it has they can color code it to show the electricity consumption of a building, from a building all the way drilling down to an apartment level or an office level. Another application or use case is this particular one, which is basically showing the solar potential of the roofs of this particular district, UWA. So these are the blue locations are the locations that has no sun shading, or it's free actually. It has whole day non-obstructive view. So solar panels can actually be put here. Yeah. Another example is obviously CFD, or computational fluid dynamics. This is actually Bishan, another district. That's that they actually do CFD simulations. Um, Another example that was actually used is this simulation of urban heat. So this is actually a project by NUS, a certain professor from NUS, and you can clearly see what is there are actually thermometers installed to various parts of the country, and then they're actually reporting live, and you can visualize the temperature gradient from this one. So obviously the green ones are the parks, the location of the park. This is actually Changi Airport. And then the heat is the heat map, and so on and so forth. So this particular portion is actually have so much heat because these are mostly the petrochemical or oil storage portions of Singapore. So you can visualize in 3D, not just in 2D, but in 3D, where the heat is coming from, and then specifically distinguish between the rural area and the city area. That's a typical example. Another one is macro level study of a particular district. So this is wind, for example. That's the wind flow at the Marina Bay area. So you can have GIS layers plus the simulation coming from virtual Singapore, and you can identify areas that actually can be naturally ventilated, or areas that is actually producing too much heat from the air conditioning. That I mean, it explains why that particular area is actually too hot. It can be on a district level. So this is typical example of a Jurong Lake district study using 3D model, GIS layers, and simulation. Another interesting part at the time that we obviously been considered is the underground. So this is basically a subsurface underground condition detection using GPR, ground penetrating radar. So as you are aware, ground penetrating radar, depending on the frequency or it can actually between 5 to 10 meters. But this particular GPRs is able to actually detect up to 30, between 20 to 30, depending on the soil condition, obviously. So if it encounters rock, it will, it's more, how to say this, it's more beneficial. But if it encounters soil, it's quite shallow. So this is actually phase 2 of the mapping. So it's not, so what I'm trying to say here is that phase 1 is pretty easy, you can walk around, take a picture, or shine a laser to it. That's basically above ground. The main challenge of virtual Singapore is actually collecting underground structures or soil conditions that have like pipelines and so on and so forth, or foundation. So that's actually the main bulk of the research, actually, the underground. I mentioned about the NEA, right? The National Environmental Agency. We actually laser scanned all the trees in Singapore, and we actually tag them one by one. And then as you're aware, trees grow, right? So trees grow, year 1 can be this foliage, year 2 can be this foliage. They actually are tagged one by one, 3D geometry, and then they have the leaf area index automatically computed, so that they will actually compute how much sun shading or shadow is generated by that particular tree. So yeah, so there's a color tag. They actually tag roughly 60,000 types of trees, in Singapore. Yeah. Another one is sound. So sound metrics. This is basically the visualization done for sound noise actually in the city. and some of the locations. So that's one project. This is actually by NTU, if I remember correctly. And another project is actually coming from NTU, which is Virtual Singapore for Urban Mobility. This is actually the autonomous driving. In Singapore, there will be an introduction of an autonomous bus in 2 years' time, I think, 2022. So we need to have a hyper accurate model of Singapore to actually move the buses autonomously, meaning to say that they can drive as fast as 80 to 100 kilometers per hour, and then they basically on a platooning mode. The gap between them is just half a meter, and then they are fully autonomous. So that's the project by this particular Professor Justin. So using virtual Singapore data sets to actually create a 3D map, and then those autonomous vehicles can actually follow that. So it can be your private car, your bus, or your taxi. So the focus at the time was actually buses. So they actually have, NTU has CETRAN, the Center for Research for Autonomous Vehicles, and they're using the virtual Singapore datasets specifically for that. Okay, so that's so far. I hope you pick up something. For questions, let's back to you, Dr. San.
Yeah. Okay. Thank you. Though that's wow. It's filming. I'm looking for popcorn. That's a great story though. So I think that the question over in kind of few technical questions. Then how different agency communicating this thing. This is a huge amount of data, right? And then different platform, different need, different use, and I think kind of mixed questions that who hosting this, who we, the head of the table to make decision. I'm going to go this way, from your participation.
At the time, there was a task force
Okay.
specifically that handles virtual Singapore, and every agency has a representative. At the time, I was the representative for BCA, Building and Construction Authority, and we actually meet every other week, if I can remember. So to decide a few things like, what format are we going to use? What the file format? Who's going to host it? How do we access it? And then the use cases by the agencies, if you remember. So different agencies actually ask for different things. So we need to harmonize them. So there's actually a national task force from the different agencies, and then they actually meet regularly to discuss their concerns or their inputs, you see, because for example, different agencies can actually, like the Land Transport Authority can actually contribute the models for the rail, road, and then the underground pedestrian, and then and parks can actually contribute the digital terrain model of the parks, for example, and so on and so forth. And PUB can actually contribute the underground models for the sewer, the water pipes and so on. So there's actually a task force that was actually meeting regularly to discuss those.
Right, that's fantastic. I couldn't imagine the conversations though, and I understand that this kind of top down is a national implementation, right? So
yeah,
I think it's excellent.
Who owns the model?
The model is actually owned by the government. So currently it's owned by SLA and GovTech. So the Singapore Land Authority actually owns it, and GovTech is actually the one who hosts it. Yeah.
And they operate as well.
Yeah, they operate it. Yeah. Yeah, so it's now fully operational. It's been 2 years. It's in 2018. It's fully operational. Before, only the public agencies have access to it, but now the public has access to it. You have to physically go there to tap into it. It's not available online. So as mentioned, right? So Geospace is Virtual Singapore is basically the 3D part, the 3D version of Geospace, which is only applicable to the public agencies. The public one has a public facing one, which is the one map. There's no version yet of the 3D version of a one map yet. Not yet.
Okay, so in this case, this kind of Geospace that toward to the end ultimately would give it away for the public, so everyone able to access.
Yeah. But you have to understand the apprehension. So, for example, yes, you can go to a 3D. You can see the 3D model of a hospital or a mall because you can walk into it. But should we show the underground structures below you? So for
Yeah.
example, these are like for example, water line, sewer
I
line.
see. I
Why would the
see. Some
public why
security, right?
why
Yeah.
would the public know that? I mean, need those information.
I see.
So some of the data sets you need to control. Yeah, that was
All right.
the
So
the
there's a certain level of authorization and in order to access this information. So on.
yeah. So basically
Okay.
the question is, if you can walk into it, I mean, if you can walk into it like a mall or a hospital or a school, yes, that is publicly available.
Hmm.
That can be publicly shared. But the most of the underground is not.
Okay.
Yep.
So what's there's a lot of huge effort here, and what's the Singapore has envisioned though in order to do this thing? What the Singapore's want?
Basically, they would like to have their own version of Google Maps. That's all. So you can as you are aware, Google Maps is like 2 to 3 years old always.
Yeah.
It's not updated on a regular basis. So they would like to have, this is their own. And then as you have seen it, the applications are endless.
Uh,
um, I just show you just a few of them actually. At the
Mhm.
time, there were actually 60 active research R&D proposals to use it. You see, so I'm only showing to you like 7. Yeah. so
Mm.
so use case. Yeah. So like CFD,
I hear you.
heat,
Yeah.
acoustics, noise pollution. These are the common ones.
Hmm.
But you have to see the interesting part. I've been part of this project 3 years ago. So
Okay.
just imagine the things that I'm sharing you is 3 years old.
I'm
Right.
probably going to ask a
Sure.
pretty difficult question to answer, I think. But
Go ahead. Yeah.
how are you keeping it up to date?
Yeah. So there was a
Because
at the
because
time.
sorry, because I know it's took you 2 years or 3 years to get to this point now, but obviously while you're creating that data, things are changing. There's new projects, new infrastructure amendments, things like that. How are you monitoring and keeping track of all that?
That was actually debated for a very long time. So I think they have at the time. I'm not sure about now, but they would like to update it every 2 years. Um, so that was the original one. I don't know if they have updated it. So as you are aware, buildings in Singapore go up just that quickly. I live
Hmm.
here. I live here already. You go to one town or district and they say, oh, there's a new mall here. I live here. Why did I I didn't see this mall?
So it seems 2 years too long then, to update
Yeah,
this
yeah,
information.
yeah, yeah. So maybe they would like to update it on a bi-yearly, twice a year or a yearly basis. Yeah. So I cannot answer that because I'm no longer part of it. But
Okay.
but that was
See.
a question that was a valid question that was actually put forward in the task force.
Yeah, it would be the top list to question this then when we want to build a new data. So yeah, well, great, excellent. So I know that you don't have the phase 2 in your materials, but do you have any insight that what is the progress right now on phase 2?
Phase 2 has, I can say, double the funding.
Double the funding.
Yeah,
Can
yeah.
I ask the first funding then? What's the
Yeah,
first
it's
budget?
publicly available. It's like 83 million. That's for phase.
Singapore dollar, right?
Yes,
Okay.
yes.
Okay.
So it's publicly available. It's like 83 or 87. I can't remember it already, but
okay.
it's publicly available. So the underground phase 2 is much bigger.
Cool.
So that is where the real action is. Actually, yes.
Yeah. Do you have any insights what how you're going to do it because we can't see it?
So there's so I mentioned about GPR. So there's a lot of focus on GPR, ground penetrating radar, because how are you going to map the thing? Let's just say you have an underground cable, buried 10 meters below ground. How are you going to map it? Are you going to dig it? And then take a picture of it? I don't think so. So ground penetrating radar, the technology of ground penetrating radar was the focus of the R&D, and then underground drones, small little drones, that can pass through to the pedestrian, the MRT lines, the railway and so on, and even sewer pipes, and then they actually looking at the possibility of small little drones that you can just drop into your toilet and then it will actually map. and so on. So I don't know. At the time,
Oh,
it's just
exciting though. I think it's very interesting on the process though. I
so.
understand the mind mapping and similarity of
Yeah.
scanning and
So,
so on.
as mentioned to you, what I'm presenting to you is just the phase one.
Right.
The real action is actually in phase two, which is
That's the challenge.
how do you map the underground. But obviously, I cannot say more than that.
I'll hear you, understand. Yep. So I think I'm already mixed up with a question from audience for sure, but just let audience know, you can throw a question in Thai, English, both. Not Chinese can read. So it's just give it to us whilst we have a discussion still. So I guess that we have seen both case study from Vietnam, RMIT. There's just excellent tools, and the way you convert this kind of data, digital twins, and both even the Singapore as well on here. So my question would be a bit more like a broader, in a big pictures then. So do you think that the countries like for the new country or maybe developing countries like Thailand or other country in Southeast Asia particularly, so i- is it good to start invent or investing this digital twin for the country or city? You know, my
Chris,
question, yeah, yeah.
I'll,
So
I'll, I'll let Chris answer first.
yeah, you talk about it already, yeah. So what do you think? What do you think, Chris?
Well, of course. I mean,
Um,
capturing this data really helps with seeing a lot of information about how cities are used, how the mobility uses around the city. You can run analysis onto the resources that cities use at the moment and potential risks for expansions of cities and information. So you can aggregate this information to do a lot of the studying even before you go into actually any design work. So I think it's highly important, and as more buildings get built and brought online, and they come into more of a smart technology infrastructure, we can leverage that data to make decisions even faster and more accurate. So if that data is embedded in methodologies into the design phase and through construction and then captured at a government level, we can start to really get insights to how our cities are actually being used and the full impact it's having within a region.
that's excellent. Yeah. What about you, Sonny?
I think before there was a lot of discussion whether this particular 3D model of a city would be a white elephant, but as you can see, there's a lot of applications. If you have your own map or you have your own model, because it's realistic, number one.
Yeah.
So a lot of simulation is obviously just simulation. So now we have hyper accurate models of districts that you can do computational fluid dynamics, for example. So I think the advantages is actually there. Yes, it's expensive. It's expensive as mentioned, but the question that I'll just give a simple analogy. Let's just say you go to a clinic, right? And then you have a nurse, and then they would like to draw blood from you, right? So the nurse is, let's just say your vein is covered by a few layers of fat. Very difficult to pick the vein, right? You have multiple tries. You know how frustrating that is. The what virtual Singapore will do is have a hyper accurate model of your vein. So the next time that you build another MRT line, another sewer line, so you don't need to dig, everything is hyper accurate. Actually, we actually color coded it. Up to 50 millimeter accuracy is actually green. Up to 1 meter is actually orange, and then if it's up to 5 meter accuracy, that's actually red. So the next time that you build an MRT line, you actually you draw blood. You only draw it one time.
Okay.
That's
Okay.
that's the
Yeah.
idea. You see,
Yeah.
that's the idea. That's the main idea. That's the simplest I can give an analogy how important it is.
I have another
Yeah.
simpler. Is that meaning, or we don't actually have good data, perhaps?
Yes, yes, yes. No, because you have, let's just say you're building a building, and then you have an as-built, so-called as-built of
Okay,
the adjacent structure. Uh,
that's the name.
it's just so funny that the name as-built, right? So
Right.
somebody just draw it. It might be the detailed design. It was not actually as constructed. Yeah,
Yeah.
so
Yeah.
that's really funny. Yeah.
Yeah.
For me, like agent-based modeling is another aspect of this, which really yields good potential for cities, not only not only existing cities, but new cities that are being built. I mean, the MIT City Labs, they've got an agent-based system
Mm,
for
mm,
their campus, and it's amazing. They move blocks around their model, and it shows the impact to the city when it comes to the mobility of the city and the way the resources are spread out, and the reaction that will have on house prices and the rest. That sort of ability to make those decisions quickly and accurately is vitally important for governments to see how that they can bring a lot more investment into the city or enhance the livable qualities of their cities. So once we start to leverage, get this data and leverage it on the digital systems, the analytics we can run. It's a lot more than just being able to identify. I mean, it's important when we're doing the construction stage, when we look at what your analogy of identifying the veins of a city for when we're doing construction, but actually analyzing how the city is actually being used and how people are living in that city, the resources that it's requiring, and how we can enhance certain aspects of the city to make it more livable is where the governments are really going to start seeing the advantages of using this data and the agent based modeling techniques.
mm. That's excellent. That's excellent. Um, there's a few questions on technical part for him from the audience. We'll talk about like maybe looking for specifically for Singapore, digital twins and asking us about GPR technique and mapping underground services. The issues about the contractors come across in order to avoiding damaging and so on. So I think somehow it's kind of mixed questions that after stacking the build up the phase 2 or even phase 3, in order to avoid or lost data or efficiency build up efficiency of the data somehow. We're looking for like any of the situation come across like flood, right? And it's this new data, it's immediate emergent data we somehow come across. So what do you think, Sonny? Is there any preparation, any thought about that, right? So
Okay, so let me just give you an example to answer that question. As mentioned, right, we have phase 1 above ground, phase 2 is below ground, and then phase 3 is geology. So the idea was the reason why there are three distinct layers was that we believe that um, uh, the above ground, below ground, and the soil or rock that you will encounter are the important ones if you would like to develop or do urban planning. For example, let's just say you are a developer of a mall, for
mm,
example,
mm, yeah,
and then the idea was if you are a developer, uh, uh, data within 5 square kilometers of your mall will be given to you so that when you start design, planning, or execution, the hyper accurate models are there for your use. So that you don't hit a particular, for example, the very big problem that is hitting underground power cables. Do you know how disruptive it is
mm,
to hit even a 66 kV power cable? To restore that will take days, and then there's no power for x amount of hours, or and then not to mention the penalties, or hitting a sewer line. Or it's okay to hit a potable water line, but sewer line, my goodness, if you hit it, um, much impact, very big impact, and so on. So that's what we're trying to avoid, you see. So we see the benefits, especially the underground, because The underground is actually how to say this is especially the soil, for example. So for phase three, what is happening is that there is seismic surveys. So so I can only describe it to you this way. So they actually have detonation, and then there are listening stations within every kilometer or half a kilometer, and then they actually map the soil type, whether it's clay, sand, whether it's rock, what type of rock, G3, G4, G6, and so on and so forth. So that's actually being done. That's actually phase three is actually already finished, actually, as if I recall it, is also finished. Because even if you have boreholes, for example, let's just say, let's go back to our example. Let's just say you're doing mall, right? And then within your lot, you actually put boreholes. Actually, Singapore is collecting almost 600,000 boreholes, and they are modeling that in 3D. So if you say,
Wow.
oh, I encountered clay, but actually, from the database, 10 meters from there is a soil log that says that's actually not clay; it's actually sand, and so on. So that we can identify, that you should do this kind of foundation. Maybe you should
Yeah.
go for board piles,
I see.
and so on and
More
so forth.
analytical, and predictions. What would be the worst case, best case, for somehow.
Yes.
Okay.
So if you submit something that is you didn't verify yourself, like for example, like the boreholes, there's actually data within
Yeah.
that vicinity. So you cannot lie, you cannot just anyhow submit
Yeah.
a bore log, because
Mm.
there's actually data that can verify, what you submitted and so on. So we see that as an advantage. So that's the reason
See.
why now the focus is actually phase two. Yeah.
Yeah. So there's a lot. Chris, do you wanna add up some?
I was just saying on the question I can see about they talked about using the models for flooding and storm. That's actually quite interesting because we're doing a lot of work in Singapore with our 3D modeling around coastal, the impact of coastal impact and environmental impact of flooding analysis. So these models can be used for that, and we're using it quite a lot in Singapore, and they do give us good insights to potential threats over the next coming 5, 10 to 20 years. So they become very valuable for that kind of analysis as well.
See.
And there was also, I also noticed a question about the weight of the models. Yes,
just about to ask.
Yes, they are very heavy, but you've got to consider what they're using for. So when during my conversation, when I talked about obviously 20 terabytes of data, and we also talked about the 45 terabytes of data that city model has. You don't use all of that data for the visualization. Some of that data is captured data for verification and the beginning stage. It's not actually what will be shown when you look at the platform. So when you look at our site lab platform that's built on top of Unity, the applications that you saw playing in my presentation are from an iPad. So even when you look at the city scale models that we built for Melbourne and Sydney, all that data is run off an iPad.
Yeah.
As long as it's got the internet connection, and we can drill into that information and get all the data analytics and everything from that. It doesn't need to be heavy.
I see. Yeah. See, I think it's a really crucial point in order to view those kind of data. And it's right real time and so on. It has to be a lightweight.
Yeah, it's about knowing what the data is used for and displaying it in the correct way. I mean, you're not gonna need to, if you're depending on what analysis you need out of the model, you don't necessarily need all of that point cloud data, for instance. As soon as you start loading that in at full resolution, yes, you're gonna have issues. But it's knowing how to link that data into the models when you need it, and so on. So yeah.
I see. My questions then, this my personal question. So if today, lesson learned from both of you, a case study from Singapore, Vietnam, of course, as well. If today Thailand, specifically, want to build a smart city, maybe not entire country, what should we do first?
Chris?
Oof.
Simple question. What should we do
question.
First? Right?
Simple question.
Smart city. Yeah.
You need to find out what the what you're trying to solve as this first. What are your ambitions for the city? What why are you building it? What is your investment going to look like? Who is going to help develop it? There's a lot of conversations that you need to have from a master planning, urban planning, and government level before you even start looking at the technology that we bring in place to help you visualize that data. And that is it's not a simple question. Because when we've looked at smart cities here, for example, we're really looking at smart technology that we're bringing into cities to enhance the aggregation of the data that we're collecting and visualizing it in a way that it can be used. Not a smart city is the way of a city that I would know it around, it being sustainable, being livable, easy mobility, those sorts of things that bring a lot of economic advancements to the country. Whether you're trying to be an innovation country where you need to start looking at innovation hubs, where you may look at bringing in research universities, hospital, and government collaboration within the cities. So it's a lot more bigger topic than just simple where you start, but you have to start that government level of what you're trying to achieve.
Okay, so it's kind of setting out the goal, the benchmark it up, and then set out the right, the right goal first, the right methodologies to bring the right peoples in. Okay, that's excellent answer. So Sonny, do you want to give a lesson learned to Thailand?
I already described how we do it, right? Not necessarily follow the example, but I think the lesson learned there is that, number one, I at the beginning of the presentation, I clearly mentioned, right, that the Smart Nation project is actually attached to the Prime Minister office. So it's actually from the top down. So it's not an idea coming from a mayor or a governor or a politician. It's actually coming from the Prime Minister. So that was a directive to actually create a 3D model. That's actually the first thing. Because if it is actually a directive coming from the big boss, everything follows. Everything. You cannot say anything because you just need to solve a particular problem. Or contribute. You do not force people to contribute. You ask them and says, this is actually a national project. So that's the first thing. So it must come from the top. The second one is really put a budget. So it's not a simple. You're not creating a 2D map. You as mentioned by Chris, right? There's a lot of laser scanners. We use actually Wriggle, Leica as well. I mentioned the Pegasus one. So that's actually you need to invest into hardware, or if it's not a hardware, get good contractors that actually has those. So meaning to say, don't be cheap. You get what you pay for. You say we always have that saying, right? So if you pay peanuts, you get also monkeys. So I think that's one. I never wanted to say that money was not an issue. It's just that there's a particular specification that we need to or an outcome that we need to do. So money was not an issue. So we just need to justify why we need X amount of dollars for this one. So as mentioned to you, right, the above ground is pretty easy. It's actually quite. It's expensive, but it was reasonable. But you see, the underground has doubled that funding. So because it's much more difficult, and you need to have an R&D to supplement what is the current technology.
I'd be interested to see how they're gonna approach that, because I mean, in Singapore, I know that they've got obviously GIS databases,
correct, yes.
And how accurate that GIS data is, because you might not need to go and scan everywhere. Because it's correct, when you start looking at using underground scanning, that is exceedingly expensive. And there isn't very many specialists in the world that actually are very good at doing it, because it's not as straightforward as just looking at a point cloud. I'd be very interested in seeing the strategy of that capture, to to see if they're going to use the GIS information first, and then focus on target areas that bring most benefit to the project.
Yeah.
That's probably.
And then the third one maybe is for me a suggestion is focus on one particular district. For example, in virtual Singapore, the focus was Marina Bay. Actually, there were
Okay.
only three: Orchard, Marina Bay, and I think Paya Lebar or Changi. So they actually focus on three or four areas only, like a pilot,
Yeah, I see.
meaning to say that, oh, I'll try
Thinking.
this GPR on this particular site. Oh, I'll try this drone and how to say this in this particular and then compare it. You see, you don't need to do drone first, or GPR to all of your projects, as mentioned by Chris. It's not a one solution that will solve all of your problems.
See.
So
See.
compare and then focus on one district. If you're happy with the result, then replicate it. If
Okay.
you're not happy, find another one.
See.
It's always like that. So we focus, for example, the examples that I show you is mostly from the Marina Bay. The reason being is that obviously that's basically even Chris has a shot of that. That's where the money shot is, right?
Yeah.
That's the city center. What I'm trying to say. So that's where the focus is at the time. You
I
cannot
see.
obviously yes, you can laser scan it. It would be very expensive if you do it for the entire country, but focus on, let's just say, Bangkok, for example, first.
Yeah.
Or a particular street, for example, your
Yeah.
your street. So I think that would be a good one. Yeah,
I
that's
see.
all.
I see. So it's kind of way fighting, find the right tools and process, right? Yeah. Okay.
Mm.
That's kind of excellent, though. I guess I just want to ask what would be my last question. Along with this, process, technical, configuration, refining, and so on. What is your greatest challenge? From this experience. It's kind of a big question. Then, along with this, if you cut off budget, okay, because you already answered it's budget issues. Management top down, well, that's the second thing. I'll cut it off. Is there anything else come across, doing the process? What is the most challenging in order to make this output and outcome right? What would be the one?
Do you mean in the aspect of creating a visualization like digital tool that we use?
Yeah.
Because the greatest challenge for that is finding the right tools and finding the right clients that are forward thinking enough to challenge their expectations and try to take advantage of the new technologies and new systems that are in place to help better manage our data. So yeah, for me, the greatest challenge at the moment is trying to find these opportunities and the clients that are wanting to push the boundaries of what is achievable.
Yeah, I think it's a good answer. Yeah, it's a good one. It's really difficult to find the right investor, right, or the right party, and so on. Sonny, you any challenge for you? I think we just back it to you then. What's the challenge for you?
I think for me
It seems everything too easy now. You give up half an hour presentation with those kind of things. Everything's simple.
I just would like to drive the point that always ask yourself, what are we going to use this for? I think that's the biggest challenge, because that's the first thing that we ask. You see, so there, as mentioned, right, there was a task force and so on and so forth, and then we asked them, oh, we're creating a 3D model of the city. What are the things that you think will do with this data set? You have a new toy now. What are you going to do with it? You see, because we don't want it to be a white elephant. So I think that's the important one. What are we going to use this for? Because yes, you have a 3D model of the city or a country, but what are you going to use it for? The biggest question that we have is that we don't want it to be a white elephant. You know, if Google can do this already, you know, on a global scale, so why are we spending X amount of money to do this? Why are we replicating what is? Can we do this in Google Maps? You know, I mean, can we just add another layer in the GIS as mentioned by Chris?
Yeah.
Can we reuse the data? Why do we need 3D models in the first place? So that was the question that we always ask ourselves, because if you're spending X amount of money, it must be for something. I think that's very important to ask. So if you're creating a 3D model of Bangkok, what are you going to use it for? So that is always the question. We already asked that ourselves and given answers. You see, that's
how
why.
long does it take for virtual Singapore? How long does it take that everyone's given answer?
Roughly 2 years. Yes. There was I attended most
That's
of the meetings.
Good year. 2 years. Okay.
Yeah.
I saved that one.
Yeah, but that is actually the reason why maybe it was not really successful, but we pulled it through because there was participation from different agencies. You see.
Right.
Yeah.
All right.
Yeah.
Correct.
And the one thing I'd like to advise is that don't reinvent the wheel. For example, we were figuring out what format to use, right? Land XML or CTGML or IFC, you know, for this particular project. So we didn't reinvent the wheel. We asked around, you see. How to say this, and then we choose CTGML because it's an open standard. Similar to Land XML, which is also open, but we see more potential, and then future proofing it in CTGML other than the other formats that's available at the time. Yeah.
I have a just kind of thought about, I think Singapore, you talk about the Southeast Asian issue, Singapore will be the first initiative, question and demanding for, BIM model submission somehow. Is there any correlations with this, after the say like build up the virtual Singapore and then, instead of keep scanning?
Yeah.
Can we reuse that one?
I was going to say, because I can see there's another question in the box which says Thailand might have big challenges with the infrastructure capture.
Yeah, that's the top.
And and that's what I was getting at before when I said, like, how do you make sure that these models aren't out of date by the time you finished? And it comes from a policy or government-led comes from government-led top-down pressure that when we're doing or working on projects, that this data is captured at the end in a way that it can be verified and used. So whether that's in a GIS system or in another 3D authoring tool that we can leverage into these systems, but that's where we start to have it in a process that these information data data models are updated regularly. So going back to where we were saying you might have a challenge in Thailand, is yes, you probably do, because that information has never been captured before. But the question you've got to ask is it really worth it capturing it right now? Is it really worth spending that amount of money to capture that data right now? Or is it better to put in policies in place that any future work that is done, it's captured and shared in a certain way and format that you eventually build the model over time?
Right.
And then you enhance that with certain government funding to enhance areas of the model that you may see benefit in, or the government may see benefit in, instead of just doing the whole thing at once.
I see. So put the energies all into the protocols. What would be an output? What type of files and use and so on.
Of course, because we always say, only 10% of the data that we create in the construction industry is actually ever used or captured correctly. So if we sort those processes out and move towards this open data environment that we're trying to move towards, and sharing that information globally, then we can bring that benefit at a much bigger scale.
Well, that's an excellent answer. All right then. So I think would be a great time. I guess that we can keep talking about this for another 2 hours for sure. There's excellent conversation and presentations today. This was my pleasure having a conversation, and I've seen great project today. this.
Yeah, great to be on here with you as well, San, and thank you,
Thank
Sonny,
you.
for joining. It's been amazing, and thank you to everyone who's bared with us and listened.
I think there's a lot of questions, though. I guess I believe, and you know, to be announced that this is not the last day for sure. We still have coming up a lot. You know, we have another sessions on Sundays talk about digital transformation. So a lot of great you know, presentation tools and tips, and the future aspect, you know, more visionary. And on Monday, of course, we talk about Chris also joining, you know, session on Monday as well, to be both representative of Vietnam and Singapore, of course. Yeah. So I think the topic on Monday is very interesting. We talk about targeting into the BIM movement. I think will be a critical conversation for sure on Monday. So for this evening and night, of course, Sonny, Singapore time. So thank you again, and appreciate for both of your contribution. And this is not going to be the last. So well, we're looking forward for the future.
Thank you very much.
Thank you.
Both of you. Thank you.
And happy Thanksgiving. Yeah.
Yes, of course.
Happy Thanksgiving.
Yeah. Happy Thanksgiving, everyone. All right. Bye. Goodbye.
you.
Have a good
Bye-bye.
night.